Hello there, my name is Harvin metric number EA18180. I'm from section 1P and I'll be presenting my assignment video to you on the Hexa counter for the microprocessor course. So let's get into it. So I'll be first explaining about the introduction. So I actually got this idea to design this counter to basically count the numbers 0 to 15, but instead of it being in decimal, which is 0 to 15, actually programmed it so that it will actually count into hexadecimal numbers. So 0, 1, 2, 3 until 9. So when the counter turns to 10, it will actually display A, B, C, and until F, which is 15. So what I used was the BEE2223 microcontroller, which are both available in the Proteus and also the Keil Vision. So it makes it easier to incorporate both of those software together. So I also connected it to a 7-segment display, which will be my output, and also a push button, which will be my input. Now this block diagram, as you can see from here, it is actually very linear. Push button being the input, it goes to the BEE2138, which is the microcontroller. It processes the coding and executes it, and then it will go towards the 7-segment display to show the hexa values, which will be the output. So I will later go on about the coding. And for today, I'll be talking about my assignment that I've done. And the assignment that I've done is actually on the counter up counter using the 7-segment display. And what it does is I've actually coded it so that it counts from 0 to 15 in hexa. So it counts from 0 to F and it loops itself back to 0 and it continues to count like that. So how have I managed to do that? I've used the BEE2223 microcontroller because it is also available in Proteus, so it makes everything more easier. And you can see that the unsigned character digital is actually, these are actually the count up from 0, 1, 2 until 15. These are these values so that it will appear in the 7-segment display based on this. And so all the codings are normal. Count, I've set it to start at 0 and it to count until 15. So it will count up until 15, then back to 0, and you get the point. And I've set the delay at 2000. What delay does is it actually either increases the speed or decreases the speed of the count up. You'll see in the simulation later. Now this is the schematic diagram I've done in the Proteus. As you can see, I've used the BEE2138 microcontroller. I've used 2 ceramic capacitors, using ceramic to get low values of capacitors, which are 22 picos. I've used a crystalline, I've used a push button for the input, and I've also used resistance at 10k ohm and also a cell for the microcontroller. So now let's see how this simulation works. If I press play, so you can see it slowly counts up. The 7-segment display slowly counts up. So from 0 to 1, 2, 3, like normal until 9, and then when it goes to the 10th number, it goes to A, because in hexa A equals to 10. And as you saw just now, it loops back to 0 and it's continued to run like that. So if we stop it here and we move on to the delay, if we lessen the delay from 2000 to 200, we rebuild it. So the hex file has been created. So if we play now, as you can see, it's much more faster than just now. This is because the delay has been shortened, so the delay between each changes of count up becomes less, so the speed increases. Let me stop it and let me increase it to 20,000, save and rebuild. So what do you get now? Now it will take longer time for it to transition from 0 to 1. This might take a while. Okay, it has happened. So this will continue until F, and it will go back to 0. So that is all from me, Harvin, and thank you for watching my assignment simulation and coding video.